Speaking of women who code and people who are great at building communities, smooth, right? Claire was actually one of the first people, well, you were the first person, sorry, to bring women Techmakers to Belfast. So we're eternally grateful for that. We try to live up to the legacy that you set for us. But yeah, she's not here to talk about that today. She's going to tell us about data magic with Elasticsearch and Python.
Hi, everyone. Can you hear me okay?
Yeah.
Awesome. So my name is Claire Byrne, and I'm a security data engineer at Elastic, the people who make Elasticsearch. I'm a data magician, if you will. The right data pipelines in the right hands can bewitch the mind and ensnare the senses. And I'm here today to demonstrate some data magic to you with the help of my wonderful assistants, Elasticsearch, AWS, and Python. So magic can be defined in a number of different ways, though the primary theme seems to be that a magician has the ability to influence events by using mysterious or supernatural powers. However, I'm only a few sentences into this presentation, and I already have to admit a secret to you. Any one of you could be standing up here. You're all technical magicians of different kinds. And within the next half an hour, I'm going to equip you with the spells and knowledge that you need to transfigure endless, unreadable, machine-generated walls of text into visualizations, insights, and knowledge. But first, let's set some expectations about what this talk is and what this talk is not. This talk is first and foremost about getting data into the cloud, Elastic Cloud, to be precise. I've worked in data engineering for over 5 years now, and there's always been a few constant questions from any project manager. Where's the data coming from? How is it being transformed? Where's the data being stored? How are we going to tell the story of this data or visualize it? We've used incredibly expensive solutions such as Snowflake and Domo in past jobs. I've used open source solutions such as Grafana, but all came with a host of issues. I started my time at Elastic and took a tutorial on Kibana, which is Elastic's visualization tool, and found that it was honestly the best of both worlds. It can be open source, it can be software as a service, and it's head and shoulders above the rest in terms of ease of visualization. I'm not just saying this because I work for Elastic. I really, really like it. Gone are my days of trying to ram InfluxDB query languages into Grafana. I can just use the neat drag and drop interface. So this gets results, basically, and results are what end users care about. Data wrangling to optimize simplicity and understanding, which is the data engineer's job. This talk is also about taking the easy path to data visualization. How many of you have spent at least a few hours writing code or queries to visualize data in the past? Hands up. Ooh, a lot of people. Cool. Me too. I've learned that when you're equipped with the right tools, data viz doesn't need to be painful. This talk is also a demo of the ease of use of Elastic Cloud, but all of the software that I'm going to show you today, apart from AWS, I guess, can be spun up for free because of its permissive licensing. The Elastic software stack started off as open source software, and it continues its legacy today. So now I'm going to cover what this talk is not. This is not a full walkthrough of the open source capabilities of Elastic. That would take far too much time. And I'm just going to show you some highlights to amaze and surprise you. Sorry, I mean surprise and amaze. That was actually a reference to like a magician in popular culture. And if you can tell me who it is, I will buy you a coffee. This talk is also not a tutorial on AWS or a deep dive on Elasticsearch or Kibana. Believe me, I wish I had time for this. I'll probably do some subsequent talks on this, but I'm only just going to scratch the surface of what's possible with this technology today. I'd highly encourage you to check out some of the open source stacks I'm going to share at the end with you, because that's the beauty of open source and permissive licensing. Anybody can set this stack up for free. It'll be self-hosted with all the hassle that self-hosting entails, but it's free forever. The only limit is your imagination. So some definitions then, for those of you who aren't familiar with the ELK stack. Elasticsearch is an open source data store and search engine. It's often used analogously with databases, but it's not a database. It's usually paired with its visualization front end, Kibana, and Logstash, Elastic's product for transforming logs into Elasticsearch readable documents. We'll also be talking about beats today, which are similar data transformers to Logstash. Python then. Who here is familiar with Python, at least passingly? Excellent. Glad to hear it. For those of you who don't know, Python is a programming language that's dynamically typed, interpreted, and often used for security or data science purposes. And then we have observability, which is actually a really, really important concept in software and DevOps. Observability is the ability to measure the internal state of a system by examining its outputs. And this was mentioned in an earlier talk as well. So hands up, who's ever had to spend time wading through logs? Yep. And I don't mean logs like the ones on the screen. Getting lost in forests is really fun. Getting lost in log files, not so much. Now hands up who enjoyed the experience of like wading through log files? Nobody? Maybe one person? No. I'll be showing you today how to have fun with your log files. So let's wave a magic wand and automate ourselves out of a job. So let's get started. I'm going to be working in AWS for the duration of this talk, but this is all easily translatable into other clouds like GCP and Azure. To begin then, I'm going to write a tiny, simple Python script, as you can see on the screen, one that outputs a random log line, sleeps for a random amount of time, and then outputs more logs. Obviously, you can do more interesting stuff with your lambdas. This is just for demonstration purposes. So I'll then upload this to AWS, and I've written a deployment shell script to do just that. I'll share all the code after this as well, because I wrote a lot of code for this. So yeah, we're going to be interacting with Elasticsearch here in an indirect way. But there's also a plethora of Python client libraries for Elasticsearch. So you can interact with your clusters directly with the aid of an API key, much like any other data store. But there's something I want you to notice here. I want you to look closely at the code on the screen. Can you all see that? Yeah. The first thing you might notice about this is that I'm using the base Python logger, but I'm also piling on something called ECS logging. Has anyone any idea what this might be? No? This is the ECS logging library, or at least the Python logging ingest part of Elastic Common Schema. This is a way of breaking down logs into defined, structured boxes in order to make sense of them and organize them in a human-readable way. So Elastic Common Schema then. This absolutely blew my mind when I was first introduced to it. Excuse me. I'd spent far too much time in the past grepping through logs with various permutations of error, exception, etc. ECS is an open source specification which is a common set of fields to be used when storing event data. It was developed to encourage users of Elasticsearch to normalize their event data so they can better analyze, visualize, and correlate the data. With ECS, your events will always be mapped the way you want them to be, with a single concise schema. So to supplement Elasticsearch and Kibana, we need to have a way to transform data from a number of disparate sources into ECS, pushing all the data through a spaghetti strainer and making it all into one shape. That's where Beats comes in. Any Hairspray fans in the audience? Yeah. Yes. In order to get our data parsed correctly from CloudWatch and pushed to Elasticsearch from our AWS Lambda, we're going to use function beat. It translates data from serverless applications in the cloud. Beats, in Elasticsearch terminology, are lightweight data shippers that can filter and shape raw data as you wish, from messy, meaningless text to categorized, predictable categories. For this particular use case, we're going to be using function beat's serverless capabilities. It can monitor CloudWatch's log groups generated by Lambdas and push these to Elasticsearch. This is the most I've talked in one go, like for 2 years. So you'll have to bear with me. So the Elasticsearch service we're going to be using for this demo today will be running in Elastic Cloud. But what is Elastic Cloud, I hear you ask? Elastic Cloud is a fully kitted out Elk stack that's hosted by Elastic. It's platform/software as a service. It takes the hassle out of self-hosting in exchange for a monthly subscription, but you can also try it out for absolutely free. I do want to stress though, all the stuff I'm going to show you today is available as open source software for free. So if you have an AWS account handy, you can replicate everything I'm going to do today. So I've done a little overhead work, just a little bit, and written a deployment script for my Lambda, which will make things a little easier. I've also created an IAM service role, which allows AWS Lambda to access any of the CloudWatch logs functionality. All this script does on the screen is package the Python requirements into a zip file, bundle it along with the script itself, and put it into a compressed archive. It then uploads it to the AWS account that I'm signed into and associates the permissions needed to export the logs to CloudWatch. I've also deployed FunctionBeat to my AWS account already and subscribed it to the CloudWatch log group. This means that whenever anything is added to the log group, it will automatically be shipped to Elasticsearch. Basically, whenever my script emits a log line, it'll go to Elastic Cloud. Magic or what? So I'm abstracting a lot in this talk, as you might see, but I want you to see how relatively easy it is to get something really powerful up and running with this pipeline in a short space of time. All the information required to tie this all together will be included in references at the end. And who knows, maybe there'll even be follow-up workshops or lightning talks if you all are keen enough with Docker and open source and what? Yes? Yes. Woo! Yeah, with Docker and open source and Terraform and woo, exciting. But I've talked a lot. Where's the proof? What do we actually see in Elasticsearch and its visualization tool Kibana when all of this is deployed? So, I'm going to play you a video now. You got to take a look at this, and I'll just talk you through it as it plays. So here we have the home screen of Elastic Cloud, and what we're going to do is go to the main menu, then go down to the Discover section, where you can look at all the data flowing into your Elasticsearch cluster. We're going to verify that our logs are going in correctly, and by searching for one of the log lines that I pasted earlier. So I put that in the Lambda, and there it is. Hey presto, abracadabra. So here you can see it's been sent to the cluster over 60 times over the course of the time span we're searching, just being generated randomly. So this proves that our FunctionBeat deployment has worked, and a FunctionBeat index has been automatically created for us. Amazing. Another interesting thing to note is the sheer amount of data that we get in a single record here. None of this has been configured by me. This is all automatically shipped to Elasticsearch. So you can see data about the underlying system. You can see even about the Lambda, about the system the Lambda is running on. You can see the log group name. You can see the logs themselves. And there's the log line itself there. And I also reconfigured it so that it would split the JSON log line into ECS, which is what you just saw. So that's awesome. We've got some logs into Elasticsearch. We've got metadata about the Lambda functions and the type of hardware it's running on. And we've got the log messages themselves. This is a very stripped down version of what I do on a day-to-day basis in my job as a security data engineer. We dogfood our own products, building global data pipelines and taking customer alerts from Elastic Security, our security endpoint, and correlating it all with various third-party data sources like VirusTotal. We then run it all through a custom suite of Yara rules and malware disassemblers and analysis tools in our own malware pipeline, which is where I work, extracting features to feed into our machine learning model. So by doing all this, we help to keep people safe from cyber threats. I love my job. But back to the task at hand, because I can never leave well enough alone. And I want you to see just a few more tricks that both I and Kibana have up our sleeves. What if we could do just a little more? Have you ever wanted to feel like a proper sorcerer and see data about all the goings-on in your AWS account? We're going to escalate from magic tricks to full-on sorcery here with just a wave of my magic mouse. So there are a few prerequisites to this kind of observability. First, make sure you either are or have permissions from the AWS account owner or administrator. Secondly, you'll need to make sure you have your credentials or the credentials of a read-only privileged service account handy. You'll need access to CloudTrail and S3 for gathering logs. An S3 bucket is created for the logs automatically when you initialize a new CloudTrail instance, but you'll need to create an SQS queue and subscribe it to the event notifications from this bucket. So the SQS queue will be used by Elastic Cloud or your Elasticsearch instance to gather the incoming events and time series them. So you can subscribe to the queue for other AWS services that you wish to monitor, but we're just going to use CloudTrail for now. For those of you who are unfamiliar, CloudTrail is an AWS service that monitors and records account activity across your AWS infrastructure, giving you control over storage, analysis, and remediation actions. So I've got another video for you, and I'll just chat through what's going on. So this is the deep magic, folks. The sysadmin's dream in just a few clicks. So we're going to get started by adding an integration to our Elastic Cloud instance. Integrations are easy ways of shipping data to Elasticsearch, and a lot of them use Elastic Agent, which is the next generation of beats. I'll be showing you how to install Elastic Agent in just a minute, but you can see just how many integrations there are. Any type of data you can imagine, really. So once we've decided what integration we want or need to use, we have to configure it. We're going to go back up here and just use the AWS integration. We could, however, use the CloudTrail integration or be more specific in what we want, but we're going to try and get data from our whole AWS account. So we need to configure it now. So this is where you're going to need credentials for a privileged IAM user that can access CloudTrail. So you put it there. I'm just going to skip over my credentials because secrets. But yeah, so this is where we put in the queue URL of the event queue that is getting notifications from S3. So you can see here my AWS account. Going to S3, yep. And we're just going to go to our SQS queue. And we're going to get the URL, and we're just going to pop that into Elasticsearch, into the Elastic Cloud console. So then we're going to toggle a whole lot of other options. We're not going to do that because there's an error there, but all of these have different configuration options under them, and you can choose to put in more event queues or other AWS services that you want. So we're going to collect all of the data that we can for now, and I'm going to show you what happens. I'm not very fast. I wasn't very fast at this in the recording. So we have our CloudTrail log ingest set up, and we can also set up Elastic Agent on any one of our hosts. So we're just going to do that. Agent, as I've said, is the next generation of beats, so it focuses on not being lightweight, but being connected to the cloud. It's like an endpoint if you use endpoints from any other software. So we're just going to set up the agent here. I'm going to put it on an EC2 instance that I've set up here. So That's like a virtual machine. And we're just going to go to the download page and download the agent artifact here. And then we're going to go to our EC2 instance. We're going to SSH into it. So we're just going to get onto the instance here. And voila. I was so worried this wasn't going to work whenever I recorded this. Because you know how key pairs can be in AWS. So then we're going to download the agent that we just copied. So the agent artifact is now being sort of downloaded to the EC2 instance. And we have to enroll the agent. So we basically need to make the Elastic Cloud instance and the agent talk to one another so that we can send data back from our EC2 instance to Elastic Cloud. So to do that, we need to, I forgot how to decompress files. So yeah, we're just decompressing this using tar, using gunzip. And I have to mention, because I'm a security data engineer, that this agent has been taken offline, so you can't just copy paste this and get onto my stuff. So yeah, so here we're enrolling the agent. Takes a wee while. And yeah, there we have it. The agent is now installed. So you can see here back on Kibana, all of these dashboards have been created for us automatically. We don't have to do anything here. You can create dashboards yourself if you want, but you can see just how much comes out of the box for you. So what's interesting then? What can I show you? Let's see Ssh Login Attempts. So obviously there's two here. These are both me, and it was accepted, and that's all good. But interestingly, there's also a built-in map showing the location of the SSH login attempts to our box. And you can see here, there have been already 9 failed attempts from somewhere in London, and 78 failed attempts from somewhere in Northern Ireland. So this just shows that you really, really do need to secure your AWS infrastructure right from the outset. Like, yeah. Then we can look at sudo commands that have happened on our EC2 instance. And if I just do a sudo apt-get update, you'll be able to see that command fed back to Kibana in just a moment. And you can see there that the agent install command. There we go. So yeah, magic, observability, it's wonderful. So you can also see just various interesting things like syslogs, like everything. And you can see our cloud trail metrics as well coming in, all in very pretty graphs. I'm a big fan. So yeah. And there's also a graph of a dashboard of the agent metrics. So if the agent ever stops working for any reason, you can diagnose why it's not working as well and redeploy if necessary. So yeah, there you have it. So I'm not going to take any questions at the moment because I'm standing between you and lunchtime. But please, please, please come and talk to me at lunchtime. Come and talk to me anytime. Not to sound too desperate. Follow me on Twitter, follow me on LinkedIn, send me an email if you've got any questions. Thank you for coming along on this magical journey with me. Apologies, my throat has been a little dry and I've been a bit croaky. I hope throughout the course of this talk, you figured out what type of technical magician you are. I think I know though. Since we're using software that can be free of charge and permissively licensed, we're not data witches, we're not analytics magicians, we're all open sourcerers. Thank you.